This is example 14 from page 54 of the Year 1 textbook. And the question says that we need to, on graph paper, shade the region that satisfies these two inequalities. Now we've got these two inequalities already plotted here. I wanted to go through with you from first principles about how we'd plot those in the first place. So let's take this first one here. So to understand where to plot that inequality, we need to understand where the line of 2y plus x equals 14 is placed on our graph. And we're going to rearrange that into the form of y equals mx plus c. So first of all, we're going to take x from both sides. So we've got 2y equals minus x plus 14. We're going to divide both sides by 2 to give us y equals minus x over 2 plus 7. So that has a y-intercept of 7 and a gradient of minus a half. And you can see that here on this graph. So there's the y-intercept of 7, and it's got a gradient of minus a half. Now, to understand which side of the line we want on that one, it's always useful to look at where y is on the initial inequality. And a good rule of thumb is that if y is on the less than side, we want below the line. And also because it's a less than rather than a less than or equal to, we plot the line itself as a dotted line rather than a solid line, showing us that we can have values that are on that line. So now let's have a look at the quadratic. So again, we're going to understand where the line of y equals x squared minus 3x minus 4 is, and we need to find the roots of this. We can also see straight away from the original equation that it has a y-intercept of minus 4. So let's factorize this one and set it equal to 0 to find the roots. So it goes into two brackets with an x at the start of each of them, and it will factorize as x plus 1, x minus 4, giving roots of x equals minus 1 and x equals 4, and there are the roots there. Now we're going to plot this line on our graph as a solid line, because in the original inequality it's greater than or equal to, and y is on the greater than side of the inequality, so we want the portion above that line. And the shaded region on our graph is the only area that meets both those inequalities.